So now time for some fun. We've talked about the intro, we've done the passive footprinting, the OSINT. Let's get to actually scanning and scanning techniques. So we have some objectives that you can describe what it is, you can describe ports and TCP, you can describe some of the tools and techniques and banner grabbing, and the types and purposes of proxies. So here are the topics. We'll talk about scanning concepts, discovery scans, port scans, several things on Nmap, including its stealth scans and options. We'll look at other scanners, including HPing. We'll look at SSDP scanning, scanning beyond an IDS or a firewall, banner grabbing, and pen testing with scanning. So starting with some concepts. The whole purpose of scanning is to discover what computers are live, what ports they have, and what possible vulnerabilities they have. So we will discover hosts, their OSs, their systems, their services, their listening ports, their applications and versions of everything, and vulnerabilities. So what's a port? A port is just a number. It represents a process on a network. That's it. There's nothing more. There are 2 bytes worth of ports. In other words, 2 to the 16. In other words, 65,536 possible ports from 0 to 65535. So when we talk about ports and open ports, a service or an application that is making itself available on a network will listen on a port. You want that service, you go to that port number. It's kind of like going to Department of Motor Vehicles, and there are different windows doing different things. Window 26 is for your picture. Windows 2 through 5 are for driver's licenses. Window 7 is for this. Window 8 is for that, etc. Ports are the same thing. You want a specific service, like a web service, you go to port 80, or 443 if it's encrypted. You want to send email, you go to 25, or something else. You want to receive email, you go to 110, 143, or 80 if it's web-based, etc. So a port is merely a number that represents a process on a network. And you have a client and you have a server. Now the client is the computer or the node or the phone or the whatever that starts the conversation, always. So the client makes a connection to the server, but not just the IP address. You have a client process running on the client, like a web browser. Now that browser is going to grab a port temporarily that is assigned by the operating system. And you should know all this from Network Plus, but we're reviewing just in case it's been a little while. The browser gets port 50,025 or something, whatever, some dynamically assigned number that it's going to give back to the operating system. It goes to port 80. It sends a packet to the IP address, but in the TCP header is embedded the destination port 80. And the TCP stack will pass that up to the World Wide Web service. And so let's say that the browser is using 50,025 and the web server is using 80. When the web server talks back, the source is 80, the destination is 5025. And this is how it works. So we can see in this diagram here, I've got a client computer that has a browser and an email program. The browser picks some port, whatever it is, and makes a connection to port 80 on the web server, because that's the port that the web service is listening on. The email program picks some other port, actually it's assigned by the operating system, it's a temporary loan, and makes a connection to port 25. When you see open ports, it implies that there are services listening. However, port numbers are completely arbitrary. They have no technical meaning whatsoever. They are assigned by convention. There is no technical reason why a web server must listen on port 80. That is simply by common agreement, by convention. And then it was finally sort of de facto standardized. So you could have ports that are non-standard. And administrators do that. They'll deliberately put services to listen on non-standard ports so that they are hopefully not discovered by port scans. Because port scans usually only scan the most common ports. They don't scan like all 65,535. we don't use port 0, so it starts from 1 to 65535. Anyway, so network ports identify a process on the network. The server listens on well-known ports for incoming connections. The client has dynamically assigned ports, and it makes the connection attempt. And by the way, there's both TCP and UDP ports. So we know that a port is simply a number. It just represents a process on a network. There's 2 to the 16th total number of ports. The well-knowns go from 0 to 1023, but we don't use 0, so it's 1 to 1023. The so-called registered, which the operating system will register for services and applications, 1024 to 49151. If you are a client app, like a browser, you will be assigned something dynamic up in this top upper range here. It is important for a pen tester to know all the popular port numbers and services. You should know this from Network Plus, but in case it's been a while, you should memorize that port 21 is for FTP, 22 is for Secure Shell, 23 is for Telnet, 25 is for SMTP, sending mail, 53 is for DNS, TCP or UDP, UDP for queries, TCP for zone transfers, replication. 80 is for a web server unencrypted. 88 is for Kerberos, which is, among other things, the authentication protocol used in Microsoft Active Directory. 110 is for POP3 for receiving your email. 111, which is the Unix Linux port mapper, which is basically for remote procedure calls on the NIX machines. That's specific to NIX. If I see 111, unless it is a honeypot, in other words, a decoy, I know this is not a Microsoft machine. Conversely, Microsoft has its own RPC port, 135. I see 135, I do not expect Linux, Unix, FreeBSD, Macintosh. 139 was the old legacy file and print, SMB. 143 is the other email protocol, IMAP, interactive as opposed to POP, which is non-interactive. 161 and 162 is for SNMP. Right now we're only using the UDP versions. 389 is for LDAP. That is the search and edit protocol of Active Directory. It's actually for any directory service that is LDAP compliant, but Active Directory is where you're most likely to see it. 443 for HTTPS. 445, this is the login port for the login service for Microsoft, but it's also used by SMB, Server Message Block, the file and print service. 3389, Remote Desktop Protocol. 110, POP3, 111. So we've seen all these. You need to know these. So how does TCP work? There's a handshake. And the purpose of the handshake is to establish a session and to get a starting sequence number. So it goes like this. Client server. The client always initiates the session. That is the network definition of a client. The client sends a TCP SYN packet. In other words, a packet with the little synchronize flag raised, saying, "Hi, I'd like to start a session." The server sends back a SYN ACK, saying, "Hi, okay." And the client sends back an ACK, so it's a three-way handshake. This way, we start with sequence number 0, and we start from there. That is the way TCP always starts its sessions, with a SYN, SYN-ACK, ACK. And the SYN always starts at 0, and the acknowledgement is whatever I last got from you plus 1. So as the server sends back a SYN, that too will be 0, but the ACK, because I already got your 0, will be 1. The client then sends back an ACK, which is also 1, and then we take it from there. TCP header. Now, you don't need to memorize this, but you need to recognize some important things about this. So what does a TCP header have? The source port, the destination port, the sequence number, the acknowledgement number, and it has these flags. So the important flags for us are the SYN flag, meaning I want to start a session, the ACK flag, meaning I acknowledge something from you, the FIN flag, meaning I'm done now, thank you very much, and then push and urgent. Urgent means get this to the top of the stack, and push means send it straight to the application. We use push a lot when we post or log in. And then reset. Reset means there's no service listening on the port you're trying to reach. So this is the TCP header, and you should be aware of at least some of this. So revisiting the TCP flags, this is a Wireshark capture. We see the flags, so like this one right here with the little 1 on the SYN means this is the starting of a connection. And I can see that the source port is this here, but the destination is 80, meaning that this client is trying to start a session with a web server. And it's just raising the SYN flag. The window size is the client telling the server how much traffic in bytes it can receive before it's full, and the server has to wait. So we want to know these TCP flags. Packet crafting is merely the act of checking these little flags and checking sequence numbers and manually manipulating the flags, the sequence numbers, the acknowledged numbers, the urgent, whether it's urgent or not, the window size, the source and destination port. It's the act of doing this purposely rather than letting it happen naturally. And why do we do this? Because there are many personal firewalls as well as regular firewalls that will behave strangely if weird flags are raised. In other words, they'll let traffic pass when it shouldn't. So that's why we do it. There are any number of packet crafting tools, including Nmap and HPing3, and loads more. Can we scan IPv6? Sure we can. They have 128-bit addresses, but the traditional scanning techniques will take way much longer, so you don't want to use traditional techniques. In fact, some scanning tools don't even do IPv6. But we could gather IPv6 addresses from network traffic and logs and header lines in email and news messages, etc. If we do discover and compromise a host, we could then probe other addresses on that segment. So that is some basic scanning concepts.